What is up? या हम लोग एटॉमिक स्ट्रक्चर की और बात करने वाले हैं आज। हाइड्रोजन स्पेक्ट्रम तो हो गया, तो डुअल नेचर ऑफ मैटर। ओके, so light can behave like particle and a wave. Okay, but आज हम लोग बात करेंगे particles behaving like a wave. Crazy but true. Electrons, protons, all microscopic particles. You matter, you are a wave too, but your wavelength is not very strong. The aura that you have, kidding. We'll talk about all of this. ठीक है, so आज लुई de Broglie, the French physicist and aristocrat, उसके बारे में हम बात करेंगे. Yeah, de Broglie wavelength and all of that. Also हम लोग figure out करेंगे Heisenberg's uncertainty principle. These two ideas are generally tested, JEE, NEET, all tests. And they're also very interesting from the quantum mechanical point of view. ठीक है, शुरू करें. As usual, let's open up NCERT and देखते हैं कि NCERT में कहाँ है. Where are we at NCERT? मेरी आवाज साफ आ रही? Are you able to hear me and see me? Hi Aditya, motivation जी, and दिव्यांका जो अपना मैसेज रिट्रैक्ट कर रहे हैं. This is weird. People can. What's up? Hello. All right, cool. Let's go. Window capture. Yeah. Oh, what is this? I just did a session with your friends. NEET और JEE main में क्या फर्क है? That's what this is. Anyway, where are we at? ये सब चीज जो मैं टिक कर चुका हूं, we have done in part 1, part 2, part 3 and part 4. Okay, all of these has been done. ठीक है, we are going to talk about these 2 points specifically. So let's go over NCERT का that portion जहाँ पे ये करते हैं. If you look at this, we'll look at Bohr's limitation also. Okay, 2015-2016 की NCERT है. That's top of my head, थोड़ा छोटा लिखा है. Page 46. Okay, Victor Louis de Broglie. Okay, French guy, weird pronunciation. That's his name. Okay, but he did some crazy things in the quantum world. This to start with, and the next point being this. ये दोनों हम लोग आज करेंगे. There are two broad equations. Let's figure out how to apply them. Okay, and what is the meaning of this lambda equal to h by p, etc. ये सब लोग figure out करेंगे. Yeah, a couple of numericals, and this is the second idea over here. और क्या? बस that's it. Just a couple of pages from NCERT, but couple of really important pages because irrespective of what test you're giving, this is tested time and again. Okay. And I'll introduce a little bit to the quantum mechanical model of an atom. Recap of everything we've done so far, एक दो शब्दों में, एक दो pages में, then we'll go for this. Okay, ठीक है. और अगले वाले में tomorrow, Thursday, Saturday. Tomorrow तो हम लोग IIT का पेपर करें. This will happen on Saturday. Oof. H psi equal to E psi. What is this, bro? Hamiltonian. ये सब काहे दिया है NCERT में? ठीक है, दिया है तो we will talk about it. Anyway, any which way, let's go with today's session. I'm great. How are you doing, Ritika? Priyanshu, what is up, bro? Gyanu. Okay, cool. Pathway to the quantum mechanical model. Look at this handsome devil. Look at him. Look at that. Same Z's, right? Just need a bit more hair. Louis de Broglie. Einstein, he suggested that light can be a particle or a wave, which is crazy, mind-blowing stuff. दोनों कर सकता है. Light can do whatever it wants. Okay. Louis de Broglie, he's like, ठीक है भाई, particle भी ही करेगा. Particle has dual nature as well. It behaves like a wave or like a particle. Yeah, thank you, Einstein. Literally, particle behaves like a particle. It behaves like a wave. What does that mean? Does it mean that this can behave like a wave? Like this has some frequency and amplitude? Let's see. That's what we're going to see. Namaskar, Nidhi ji. Welcome. Hi, Aakash. Great. Thank you. How are you doing, Nidhi? That's great. Thank you for joining in. This is what he said. He said that the lambda or the wavelength of a particle, the pen, is given by h by p. Hold up, h is a really small number. H is 6.6 into 10 power minus 34 into its momentum. Well, this pen is not moving. Let's make it move. Oh, it's moving really slowly. Zoop, that's 1 meter in 1 second. My hand hurts doing that. If you throw the pen, it's probably going to get 3 or 5 meters per second. Okay. What is the mass of the pen? 10 gram. 10 gram into 10 power minus 3. Okay. And velocity क्या होगी इसकी? Say I have a great, very strong arm and I can throw it at 5 meters per second. 5 meters per second. This doesn't seem like a very big number, does it? 5 into 10 is 50. So ठीक है, 1 point something. Maths is amazing, isn't it? 1.3 into 10 power 3, 5, okay, 10 power minus 31 meter. Wow. I guess that's the aura of the pen. 10 power minus 31. How is that? Small, right? So it's not, doesn't matter. does not matter. Matter waves don't matter for this pen, but they do matter for really fast particles and really low mass particles. Okay, this pen, 5 meter per second. That's all I can throw at. 5 meters is a lot, and mass bhi zyada hai. Now, what if I took something that had a mass of 10 power minus 31 kilogram, and I took something that's moving close to speed of light, 10 power 6. Electron 10 power 6 meter per second jata hai. The moment I do that, that number becomes relevant. वाह, मोगली जी देखो, अलग ही चीज कर रहे हैं. मोगली जी, I think you should get one of those AI models that directly translates what I'm saying into whatever language you want. There's an app called AirChat that I use. It does exactly this. Yeah. If you want, you can record exactly what I'm saying. You can download this app right now. It's called AirChat. It looks like this. My phone में से दिख रहा है. It's cool. Okay. Since we are doing this time pass mode में हम लोग हैं, ठीक है बोलते हैं. So I've got a student on my live chat right now who's saying that I should talk in Telugu. I obviously don't know Telugu, so I'm telling him to download AirChat. I'm doing this live, right? Because why not? I'm telling him to download AirChat, and I'm going to show him that what I'm going to talk translates into whatever language you want real time. Okay, that was my message, and you can see that it translates into it in real time. Okay, and you can put it in whatever language you want. If you want, I don't know if they support Telugu right now, but we are taking this small diversion to tell you that AI says it's possible. It's possible. Okay. देखो टाइम पास कर रहा था, मैंने भी टाइम पास कर लिया. ठीक है. If you're serious, I'm serious too. You can figure this out with AI. You can put whatever I'm saying into AI, and it'll give you real time में Telugu में. It's not a distant reality. It's going to happen. So language is not going to be a barrier very soon, which is brilliant for a beautiful nation like India. So lambda equal to h by p mv. Okay, we're not going to go to the derivation of this. It's beyond the scope of anything you want to discuss. If you want to talk about the derivation, kaise hua, kya hua, you know where to find me. You know where to find me. Where to find me? Whoa, 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 whoa. Sorry about that. Something became just moved around too much. Hold on. कहाँ गया वो link यार? I didn't have that copied or what? One moment. Uno momento. Please. Hold on. I can listen to myself. Not good. Not good. Where is the description of this? There you go. Description में तो ये चीजें हैं ही, but मैं यहाँ chat में भी डाल ही देता हूँ. ठीक है? अरे दो space bar डालो, space bar. There you go. So there are two links there. One link goes to my servers, Discord server that I run for discussions. The second link is even more important. It lets you download the app if you're on your phone. Let goes to the Aakash Byju's app. Brilliant content, self-study करने के लिए. We can find derivation there, or we can chat about it elsewhere as well. Hey, Yuvraj, what's happening, bro? So, anyway, let's at this point accept that Louis de Broglie did some wonderful work and said that lambda of any particle can be given by h. h क्यों? Well, E was h nu. उस समय भी आपने पूछा नहीं h क्यों, तो अभी भी मत पूछिए h क्यों. Beyond our discussion, okay. The short answer I can give you is कि some crazy things with complex numbers and wave equations. You know, what's a wave equation? You have a, when you do this concept of a spring ka motion, right? Minus kx square equal to something. You will understand this better. So once you're done with this, come back to me. I'll maybe derive this for you just for fun. Khair, what this tries to say is as momentum increases, lambda kam hota hai. मतलब अगर momentum कम हुआ, lambda is relevant. So our focus is this part of the graph. मतलब very, very low mass, okay, small mass, and very high velocity, okay. Why high velocity? We'll see. Because small particles generally have high velocity. But mass इतना छोटा है कि velocity ज़्यादा होने से कोई फर्क नहीं पड़ता. Velocity की limit है ना. Speed of light से ज़्यादा नहीं जाएगा. At least for you and me. ठीक है. Let's take a question and figure it out. Oh, all right. Money, Pranav. All right. F equal to minus kx. Is that what it is? Yuvraj, for spring constant? What about, isn't there some kx squared term? I think it was, okay, maybe I'm saying this wrong. D square x by something. It was second differential of something. D by dx. I'm bad at this math thing, but basically the second differential of this. How do you write the second differential? Dx dy by dt is the first differential. D square y by dt square would be the second differential. Okay, so second differential of basically some function is equal to minus kx. That's what it was, right? Okay. We'll talk about that. वो कल हम लोग बात करेंगे. Saturday is when we'll talk about all this. Yes, energy is half kx square. Yeah, thank you. Let's talk about this. A beam of helium atoms move with a velocity of 2 to the 10 power 4. Find the wavelength in picometer of the particles constituting the beam. Now you see, मैं बताया, I gave you a rough idea of this pen thing. It was not very relevant, right? But this is relevant. A helium atom को लो. What is a helium atom? It has a mass 4 AMU. What is AMU? Which is 4 into 1.67 into 10 power minus 31 kilogram. 31? नहीं 31 नहीं, कुछ और था. 10 power minus 27 kilogram. Minus 24 gram, 27 kilogram. Okay. वेवलेंथ निकालना है कैसे? लैम्डा इक्वल टू h by p. What is h? h is 6.6 into 10 power minus 34. मैंने सब आपको दे ही दिया है. This is the mass. वेलोसिटी दी हुई है. थोड़ा एफर्ट लगाइए. प्रणाम आर्ट जी. हाय सुमन. मोगली जी बताइए. You can also do this. Use the language of math. You're getting full stressed. मणि दीपक जी गुड इवनिंग. प्रणाम. स्ट्रेस तो नहीं लेनी चाहिए लाइफ में. स्ट्रेस बिल्कुल नहीं लेनी चाहिए. भगवान देख लेंगे. भगवान का नाम लो. ट्राई करो. भगवान भी उनकी देखते हैं जो तुम. They have to try themselves. Keep making efforts. Sure. Please. So try. In the spirit of trying things out. Can we try this question out? Yeah. Take a minute. What's happening? युवराज अब तो दूसरी चीज बोल रहे थे. इसके बाद इसको ट्राई करेंगे. चलो I'll give it प्रॉपर इक्वेशन. ठीक से लिख देते हैं. वेलोसिटी इज दिस. लैम्डा इज h by mv एंड m क्या होगा? m ऑफ अल्फा पार्टिकल. अल्फा नहीं, ठीक है, हीलियम में लिख देते हैं. अल्फा तो बोलने की आदत हो गई है. मास ऑफ हीलियम इज व्हाट? 4 AMU, atomic mass unit. So let's substitute all of that. It's not rocket science, right? Mass of helium into velocity. 6.6 10 power minus 34, 4 into 1.6 and 10 power minus 24 gram into 2 into 10 power 4. Okay, well, let's do another 10 power minus 3 here to make it kilogram. Kilogram per gram, right? So gram cancel out, kilogram again. Okay, now what do we do? Let's cancel stuff out. I feel we can cancel a lot of stuff out. You do this, you get 1.6. 1.6 becomes 1. अरे बचा क्या? तो looks like it is 1 by 2 into 10 power minus 34 plus 24 plus 3. मतलब it is 0.5. ये क्या हो गया? 0.5 34 24 10 हो गया. 10 3 7 हो गया into 10 power. नहीं, कुछ तो हम खा गए. अच्छा, ये और भी चीजें. -4. Okay, so 4 and 3 becomes -1. -1 and this becomes 23. Yeah, we are good. It looks like we are getting the healthy answer. 0.5 to 10 power minus 11, which is 5.0 into 10 power minus 12. So मेरे हिसाब से answer should be D. What do you think? Nidhi retracted their message. That's all right. Don't worry about it. So get used to doing this arithmetic. Okay. The reason why I am solving this question with you is to show you कि चीजें cancel out करना last में करो. Don't try to substitute stuff. And usually हो जाता है. You do 10 of these questions, you'll get an idea. देखो, h अगर न्यूमरेटर में है और मास ऑफ AMU अगर कन्वर्ट करना है वो डिनोमिनेटर में है, it will become 1:4. Yeah, take a calculator if you don't believe me. Do 6.6. Okay, let's do that. 6.6 divided by 1.67. You get 3.95, which is approximately 4. Approximately 4. 3.95 is what you get. Okay. Please don't mug this. आप इसको 10 बार करोगे आपको खुद याद हो जाएगा. ठीक है? Answer is 5 picometer. Okay. So a helium particle has 5 picometer का length. 5 picometer फिर भी थोड़ा छोटा है. Okay. It's kind of small, but still detectable. It's small but detectable. These guys, they proved de Broglie का prediction. By the way, de Broglie की मोड़ का फ्रेंच बनता है यार. आप अगर अमेरिकन हो तो आप de Broglie भी बोल सकते हो, जैसा आपको ठीक लगे. ठीक है? Because our man is French, hence I'm saying de Broglie, because that's how they pronounce his name. It was observed that the electron beam undergoes diffraction. Hi. Diffraction क्या बला होती है? Anybody knows? Chat में. What is diffraction? Have you heard of diffraction? Have you heard of diffraction? You'll study about this. कहाँ? Perhaps in wave optics and ray optics. There are two branches. In one of these, you will study this. किसमें पढ़ोगे मालूम है? लग रहा है कि अभी जनता 12th की नहीं है. It's okay man, क्या करें? Atomic structure is one of those things जो आपको जबरदस्ती 11th grade में पढ़ाया जाता है, which makes me the bad guy, the person who's teaching you, the chemistry person who's teaching you this makes them the bad guy. What to do? But these are complicated ideas, and without doing all of these, this seems a little random. +2 physics, yeah, +2 for sure, but किस chapter में? Yeah, खैर, we'll see. जब आएगा तब कर लेंगे. So what he saw was a cricket ball, not he, the wavelength of an electron, right? Let's compare. Cricket ball का example लेंगे, मैंने पेन के साथ बताया था. Let's take a cricket ball. 150 ग्राम की भारी सी cricket ball. 25 मीटर सेकंड, बहुत जल्दी. What is 25 मीटर सेकंड? 25 मीटर पर सेकंड कितना होता है किलोमीटर पर आवर में? kmph. आवर चाहिए मुझे. ठीक है, न्यूमरेटर. ओके, सो आई विल डू 3600. No, doesn't make sense. I will do 3600 numerator. 3600 second per hour. Correct? Okay, great. मीटर कितना हो गया? Into I will do 1000 मीटर per kilometer. Okay, great. Okay, okay, okay. So क्या हो गया? 18 by 5 सही हो गया ना? 18 by 5 is good. Multiply this with 20. 18 by 5. ठीक है. तो 25 into 18 by 5 करना पड़ेगा. Okay. That is the wow, that's very fast. Huh? 3.3. Close to about very slow cricket ball actually. 80 kilometers per hour. बहुत धीरे चल रही है बॉल तो. ठीक है. 80 मतलब स्लो स्पिन बॉलर आई गेस. सही किया मैथ्स में. 25 meters just that. 25 into 18 by 5. 90 है. चलो. Sorry, not 80. Bad math. 90. फिर भी स्पिनर की बॉल या फिर स्लोअर बॉल फ्रॉम योर फास्ट बॉलर्स. मास ऑफ इलेक्ट्रॉन 9.10 पर -31 किलोग्राम. बहुत छोटा है. वेलोसिटी स्लो. दिस इज आल्सो स्लो, नॉट वेरी फास्ट. व्हाट इज वेलोसिटी ऑफ लाइट? लाइट की वेलोसिटी इज 3 to 10 power 8 मीटर पर सेकंड. तो उसके कंपैरिजन में स्मॉल स्लो है. इट इज नॉट स्लो. 2000 मीटर पर सेकंड इज फास्ट ब्रो, रियली फास्ट. लुक एट द लैम्डा कैलकुलेशंस. कैंसिल करेंगे क्यों नहीं करेंगे? सब कुछ कर रखे देखो. ठीक है. इसमें तो कुछ नहीं कैंसिल हो रहा है, इसमें तो कुछ कैंसिल हो रहा है. ओके, ठीक है. दिस बिकम्स 1 2/3 पर अप्रोक्सीमेटली. अगर 3 करो तो ठीक है. 2.2/3. ओके, 1.1/3. So it's 1/3 into 10 power -34 plus 31 minus 3. अच्छा, तो 5 हो गया. 1/3 into 10 power 5 मतलब अप्रोक्सीमेटली 333 नैनोमीटर हो गया. राइट, approximately 333 nanometer हो गया. If you do the actual math, you get 364 nanometer, which is great. This is visible spectrum. You remember visible spectrum होता है 350 to 750 nanometer. We have done all this in the first session. Okay, अगर ये याद नहीं है तो एक बार देख लो. What is the visible spectrum of light? Balmer series में क्यों visible होता है, etc., etc. वो सब यहाँ पे कहते हैं. And look at this. Look at this wavelength of a ball. 10 power -34. That is pointless, right? Am I a wave? Yes, Komal, you're a wave. Hi. I'm a wave too. Look at that. I'm a wave. So 10 power -34, but wavelength's really small. Like pointless, right? Pointless. 364 nanometer. Yeah, visible light. So an electron, whoa, does this mean that if an electron moves this quickly, I'll be able to see it? Well, sight is a little bit different. Okay, अगर आपको कुछ देखना है, that's a little bit different. I'm able to see my hand or the shirt to be whatever color. Light is going here, absorbing something and coming back to my face. So seeing an electron is not that easy. Seeing an electron, a little more complicated than जो मैंने यहाँ पे लिखा है. All right. So here lambda is significant, not significant. Here it's not very significant. Cool. So here's the huge thing, right? If the mass is high, lambda doesn't matter. If the mass is low, it's great. Let's look at a very interesting way of looking at this de Broglie's equation, right? De Broglie भाई साहब ने बात की मोमेंटम की, बट ये मोमेंटम एक अजीब चीज है. मोमेंटम इज नॉट समथिंग वी मेजर यूजुअली. व्हाट डू वी यूजुअली मेजर? किनेटिक एनर्जी. यू रिमेंबर फोटो इलेक्ट्रिक इफेक्ट में वी वर लाइक, ब्रो लुक एट दिस इलेक्ट्रॉन मूव्स एट सच अ फास्ट स्पेस, राइट? किनेटिक एनर्जी ऑफ इजेक्टेड इलेक्ट्रॉन क्या होती है? 1000 बार सवाल पूछा जाए आपको. So it wouldn't be nice if we had kinetic energy here somewhere. It would be very nice, wouldn't it? Let's do it. Let's do that. So we'll modify the de Broglie equation a little bit. Say kinetic energy half mv square. You know this. What is P? It's momentum. What is P square? M square V square. What is P square by 2M? Oh. Did you catch that? I'll say one more time. M into V whole square is 2 bar kinetic energy times 1 more M. Basically, into 2 into M is what? It is M square V square. Okay. So mv p is equal to under root 2ke times m, or p square by 2m equal to kinetic energy. Small derivation, whatever you want to call it. Very useful. Okay. This is what I wanted to take away from you. This is superly important. Okay. Super important right here. I'll give you these slides. You don't have to remember anything. Huh? Jai Shri Krishna. All right. I'm not sure, man. But all the best. You're talking about advanced? You get a good. You'll get something good, bro. Yeah. मैथिली वेंसडे हो गया ना. ट्यूसडे को तो दो चीज हो गई नीट की. मैथिली आई नो. थैंक यू फॉर ज्वाइनिंग इन. मैथिली व्हाट हैपेंड वाज नीट के कल दो सेशन हो गए. व्हाई? बिकॉज देयर वाज सडन अनाउंसमेंट्स एंड वी वर ऑल वेटिंग कि अरे नीट का ये रिजल्ट हो वो रिजल्ट हो. तो बोथ दो सेशंस आई डिड. आई डोंट नो इफ यू बीन फॉलोइंग दोस थिंग्स. हेंस हियर आई एम. डोंट वरी. होते रहेंगे, है ना. ऑल राइट. सैटरडे को वी आर गोइंग टू बी डूइंग पार्ट 6. ओके. कितने एग्जाम्स आ रहे हैं ना मैथिली. आईआईटी का एग्जाम है. आईआईटी नहीं, आईएटी आईसर एप्टीट्यूड टेस्ट. दैट्स ऑन द 9th. तो उनके दोस्तों के लिए कल मैं कर रहा हूं 2022 और 2021 के पेपर्स. फन टाइम्स. इफ द किनेटिक एनर्जी ऑफ अ प्रोटॉन, सॉल्व करते मैसेज एवरीबॉडी एल्स. If the kinetic energy of a proton is increased to 9 times, the wavelength of the de Broglie wave associated with it would become. Aye, sir. Yes, absolutely. हाँ निधि. Jack of all trades, master of some. Of course I teach. Yeah, so I'll show you guys. You try this question, and in parallel, I'll also show you what all I teach. What do you need? Two things. Kinetic energy, half mv square. Lambda is h by p, lambda is h by mv. What is kinetic energy? P square by 2m. Use these things. Please solve this question. You'll be able to do this very quickly. क्या यहाँ पे दिया हुआ है? Ke dash is equal to 9 times Ke. And what it's saying is कि lambda dash equal to how many times lambda. That is what is being asked for. ठीक है? And since Nidhi asked कि भाई, do I teach on the NEET channel? Of course I teach on the NEET channel. Let me show you guys what I do on the NEET channel. One moment. कहाँ गया ये? अच्छा, I already have this open, right? Can I do like a history thing on this? I think I can, right? I was just showing this to everybody. Class 12. Okay, this is right here. This is awesome. Control H. And what were we doing here? Class 12 chemistry. All right, great. All right. 1/3, Mathli. Thank you. That's a quick answer. Love it. I think you're absolutely right. But quickly, we'll take like 30 seconds to talk about what other stuff I'm generally up to. So these are all the sessions that I'm doing on the NEET channel. And I'm doing 12 sessions there. So if you have any friend who's doing JEE or NEET, it doesn't matter. Either way, solutions कर रहे हो, solutions are the same, right? Questions अलग होते हैं, but theory is the same. Solutions kinetics अलग बन जाओ. I'm going to start electro. I'm going to do electro on Saturday there for your NEET friends and also JEE friends who want to study. And this is what I've been doing on the JEE channel. This is one track. And all of this links are there on this bento thing, Discord links as well. All right, back to this. 1/3. I like that answer. Let's see. How did Mathli get 1/3? Komal ji, I think you should practice questions. The more questions you practice, automatically theory का revision होता जाएगा. ठीक है? So कैसे करें? As soon as you get down the chapter, do NCERT inside out, do exemplar inside out. That's your top priority. That's what you should be doing. So if Ke dash is 9 times Ke, P dash is 3 times P. Why? Because Ke kinetic energy is proportional to P square. ठीक है? है ना? Cool. You said. So basically P is proportional to root Ke. That's all. So P dash will be proportional to, basically will be equal to, in fact, 3 times P. That's all I'm saying. यही तो मैंने यहाँ पे लिखा है. Okay. अगर P dash हो गया 3 गुना तो lambda dash हो जाएगी 1/3, which is absolutely right. Good job, Matthew. Thank you for that answer. Excellent work. Next question, another one. The mass of an electron is 9.1 into 10 power minus 31 kilogram. If its kinetic energy is 3 into 10 power minus 25, calculate its wavelength. The interesting thing is all these numbers are the same. You only have to figure out this. By the way, just to keep things interesting, most of the questions I'm giving to you are either from AIPMT, from JEE, AIMS, NEET. JEE एडवांस के कम है, बट ये सब के ही सवाल मैं आपको सॉल्व करवा रहा हूं. आई एम जस्ट नॉट टेलिंग यू कि कहां के हैं, बिकॉज द मोमेंट आई पुट दैट एग्जाम का नेम ऑन टॉप ऑफ माय हेड, यू विल बी लाइक अरे ये तो मुश्किल सवाल है, मैं नहीं कर सकता हूं, मैं नहीं कर सकती हूं. यू एंजाइटी कम्स. कुछ नहीं, यू कैन डू एवरीथिंग. या जरूर निधि भेजिए. अननोनी अंजुन जी, पढ़ के आइए, समझ में आएगा. अगर आप एक्सपेक्ट कर रहे हो कि वीडियो देख के समझ लोगे तो भाई हो गया आपका नीट या जेई या जो भी कर रहे हो. एनसीईआरटी पढ़ के आइए. तब समझ में आएगा, नहीं फिर कहाँ समझ में आएगा। भगवान भी उन्हीं की हेल्प करते हैं, वो हेल्प देमसेल्व्स ब्रो। The mass of an electron is 9.1 into 10 power minus 31 kilogram. If its kinetic energy is some value, calculate its wavelength. Same idea यहाँ पे. We're going to use lambda equal to h by p again, and kinetic energy is p square by 2m. We just done the derivation. So lambda is h by under root of 2m times ke. Not really a derivation, but straightforward idea. Please try it out. It'll take you a minute. I'll give you a minute. Please go ahead and do this. Go ahead. Try करिए. Doable, very doable I feel. So tell me one thing. Have you done this theory before in your life, or is this the first time you're doing this theory? If this is the first time you're doing this theory, bro, my suggestion is please go and read NCRT. It is close to impossible to do things. I mean, if you're expecting कि भाई हम वीडियो देख के कर लेंगे, that's not going to work. अरे अननोन जी, आपने बहुत बड़ी बात बोली है. मेक न्यू फ्रेंड्स अननोन जी. इफ यू थिंक, अगर आपके ऐसे दोस्त हैं जो इतना बात नहीं समझ पा रहे कि भाई जेई और मेन के लिए एनसीईआरटी इज द मेन थिंग. खैर अननोन जी, एक आपको सजेशन दूं, एंड आई एम योर एवर वेल विशर. ओके, मैं जो भी बोलता हूं आई से इट सो दैट यू कैन परफॉर्म योर बेस्ट, यू कैन बी योर बेस्ट सेल्फ. ओके, रुको, उनको ये वीडियो दे देना और आप खुद भी देखना अननोन जी, ठीक है? सब चीज के लिए मैथिली, वेदर इट इज ऑर्गेनिक. यार अननोन, इस बार तो जेई एडवांस की भी चीजें डायरेक्टली आप फिजिकल की कर सकते थे जस्ट बाय डूइंग एनसीईआरटी. नो जोक्स, ऑलमोस्ट ऑल ऑफ फिजिकल केमिस्ट्री कुड बी डन जस्ट बाय डूइंग एनसीईआरटी. तो जो एनसीईआरटी नहीं कर रहा, उन्हीं का मजाक उड़ जाता है भाई एग्जाम में. एनीवे, ऑप्शन ए मैथिली बोल रही है, देखते हैं. गुड जॉब मैथिली, यू आर क्विक, यू आर अमेजिंग. सो इसको इतनी जल्दी मैथिली ने कैसे किया, एंड अननोन जी आप इतनी जल्दी कैसे करेंगे, देखते हैं नेक्स्ट टाइम के लिए. देखो, अरिथमेटिक है, यू हैव टू गेट क्विक विद नंबर्स एंड रूट्स एंड ऑल ऑफ दैट. 6.62 into 9 into 3, ठीक है, क्या करें यहाँ पे. देखो 9 को बाहर निकाल सकते हो, बिकम्स 3. ओके, सो आई हैव गॉट 3 रूट 6, ठीक है. 31 25 is 56, 56 by 2 is 28. by 2 क्यों? If I take under root of say x, say 10 power minus 56, it just becomes 10 power minus 28, right? Why is that? Because essentially root क्या है? It is 10 power minus 56 by 2. That is literally what root means. Root means half of this, है ना? इसलिए 28 हो जाता है. So 3 into 10 power 6 into 10 power minus 28, then 6.6 into 10 power minus 34. और आपको कैलकुलेट करने की जरूरत नहीं है. 3 into root 6 क्या होता है? 3 into 2 is 8. So 6.6 by whatever, by 8 or so, मतलब 8 point something होगा. This is going to be equal to 0.89. Okay, we'll keep it as it is. ये देखो, इसको हटा के हो गया 10 power minus 6. और कुछ करना ही नहीं है. You're done. This is the answer. See, 10 power minus 6 you get. Only and only if you understand that this is 6.6 into 3 into root 6. Root 6 क्या होता है? Root 6 है. Root 4 थोड़ा है. Root 4 2 होता है. Root 9 3 होता है. So between that 2.5 होगा. Whatever it may be, the number is 0.89 only ना. So it doesn't matter. Something by a number that is bigger than that something is going to be lower than 1. Okay? अगर ये बात जल्दी लग रही है, put it on a piece of paper, it will make sense. खैर, this gives you 0.89 and this gives you 10 power minus 6, which gives you A as the answer. Good job, Maithili. Good job on figuring out jaldi. Okay, now electron as a wave. जय श्री कृष्ण जी, मुझे आइडिया नहीं है, ठीक है. कट ऑफ किसी को आइडिया नहीं है. अगर आप जेई एडवांस की बात कर रहे हैं, तो जब आएगा रिजल्ट तब हम सबको मालूम चल जाएगा. And I'll be one of the first ones, if not the first one, to come to you live on this channel to talk about it, for sure. ठीक है? Let's now talk about electron as a wave. ठीक है. ये कुछ अजीब बात लिखी है मैंने. In phase. Do you know what this is? What is the meaning of in phase or out of phase? Have you ever heard of these terms? Have you heard of these things? In phase, out of phase, phase. इसका क्या मतलब है? Phase. Current or voltage are out of phase by 90 degrees. Have you heard this at all? Basically, waves now, one leads the other. Just physical waves की बात कर रहा हूँ. If you talk about current और voltage में फर्क क्या है? Voltage and current में there's a difference of 90 degrees. That's literally, there's a phase difference. ठीक है? अब phase होता क्या है? I have sine theta and I have sine of 90 plus theta. Okay, दिस एंगल इन बिटवीन अंदर इज कॉल्ड फेज। ठीक है, तो अगर दोनों, I can't talk about this more without you learning physics, so I'm going to stop. Once you are done with wave, you will understand the meaning of what is in phase and out of phase. यहाँ पे the waves are a little bit more complicated, okay? And मैं बार बार यही बोल रहा हूँ कि the wave equation includes complex numbers, okay? Complex numbers हैं, it's not direct, but there is still interference, and it can be constructive and destructive. इसका क्या मतलब है, थोड़ा ज्यादा बोल रहा हूं मैं, बट सुन लो भी, जस्ट नोट दिस डाउन। कंस्ट्रक्टिव इंटरफेरेंस मतलब कि जो था वो एम्पलीफाई हो जाता है, डिस्ट्रक्टिव मतलब कम हो जाता है। ठीक है, तो व्हेन थिंग्स आर इन फेज, कंस्ट्रक्टिव इंटरफेरेंस मतलब जो था और उभर के बाहर आ जाता है, और डिस्ट्रक्टिव इंटरफेरेंस मतलब नॉट सो गुड, नॉट सो गुड। देयर आर थिंग्स कॉल्ड, क्या बोलते हैं उसको, फिजिक्स में एक्सपेरिमेंट्स होगा, वी विल रीड दिस व्हेन यू डू डिफ्रैक्शन। डिफ्रैक्शन जब आप करोगे फिजिक्स में, दिस विल बिकम अ लॉट मोर क्लियरर। ओके, इंटरफेरेंस और डिफ्रैक्शन जब आप करोगे, अगेन वेव ऑप्टिक्स में, रे ऑप्टिक्स में, वेव ऑप्टिक्स में करोगे ये चीजें। ठीक है, विल टॉक अबाउट इट वंस मोर आफ्टर दैट। यस अननोन जी, डेफिनेटली एनसीईआरटी इज ऑल यू नीड माय गुड फ्रेंड अननोन, है ना? बट दैट्स गुड अननोन जी, इट्स गुड टू हैव अ क्लियर एक्सपेक्टेशन सेटिंग, सो आई एम वेरी प्राउड ऑफ यू फॉर डूइंग दैट। अगर आपको लगता है कि जेई मेन ही फोकस है, डट के उसकी तैयारी करिए। उसका तो सिंपल आइडिया, सिंपल है, करना मुश्किल है, बट द प्रोसेस टू गेट स्ट्रेट फॉरवर्ड, डू एनसीईआरटी, खत्म। ओके, यस, थैंक यू मैथिली। when they interact to each other, it is called, you know, they could be either constructive or destructive depending on when they are in phase or not phase. मैंने आपको ऊपर ऊपर बता दिया है। So when things are in phase, when they're all good, there's a thumbs up thing. When they are in phase, then I can say that m lambda is equal to 2 pi r. Like, what? 2 pi r? What is 2 pi r? Well, you're going to say radius. Radius of what? Radius किस चीज का? Bohr radius का. And dude, this is a little random, okay? But I'm just going to go with this. I'm just going to go with this. You remember mvr equal to nh by 2 pi? This is the quantum idea. I did this with you when I was deriving Bohr stuff, and this was angular momentum. You remember this? Angular momentum is equal to nh by 2 pi. This is a quantum mechanical idea that we have not derived or anything, but मैंने बोल दिया, this is linear momentum. ठीक है, वो angular momentum था, this is linear momentum. Notice there is a difference of r. That's all there is, okay, between these two. When you do physics stuff, you will be okay with this. So I can use both of these ideas and I get this weird equation. This is how you get 2 pi r equal to n lambda. But इसका मतलब क्या है? What is this 2 pi r equal to n lambda? If things are in phase, then lambda is equal to this 2 pi r. Now this seems a little ridiculous because Bohr ने बोला था radius होता है, but Bohr a lot of stuff that Bohr said is wrong. But this is good. When it's out of phase, it doesn't add up. Okay? In phase का यही मतलब है कि दोनों exactly kind of overlap करके बड़े हो जाते हैं. Now see here, out of phase मतलब sometimes you overlap, sometimes you don't. It's not going to work. Extra, very, very extra things for JEE and NEET. But the derivation very simple, right? What did I do? I took linear momentum and I took angular momentum. This is the quantum mech idea. Okay. And I used, what did I use? Did I use lambda equal to, yeah, I used lambda equal to h by p. I used De Broglie bhai sahab ke ideas as well. And I derived that 2 pi r is equal to n lambda, if this ever comes anywhere. ठीक है? Cool? नहीं, जय श्री कृष्णा, कोई जिंदगी खत्म नहीं। जिंदगी तब खत्म होगी जब भगवान चाहेंगे, और that's the main thing. Okay, you are a human being who can say such things. See, an animal does not have the luxury of saying or thinking about the things that you are thinking. So what is the point of being a human being? वो आपको सोचना पड़ेगा। नहीं, थोड़ी ना point है human being होने का। Human being is such a limitless entity. Literally, every living entity is limitless. But हम लोग इन सब चीजों में बात में सोच सकते हैं, बात कर सकते हैं। तो सोचिए क्या करना है। This is a very, very big thing that we have, this human form of life. We should think about how to utilize it. ये तो एग्जाम है यार, हो गया, नहीं हुआ, नहीं हुआ, क्या फर्क पड़ता है? लाइफ में और बहुत चीजें करने लायक। Electron as a wave. Okay, in phase electron exists, out of phase electron does not exist. This is the practical idea. Okay, now we are creeping towards quantum mech. Okay, you may have heard this. इसके बारे में सुना होगा ना, क्या बोलते हैं उसको? Schrodinger's cat, dead or alive, you don't know. इफ यू टेक अ कैट इन अ बॉक्स और उसको पॉइजन दे दो, वो पॉइजन खाए ना खाए मालूम नहीं, डेड और लाइव, इज गोइंग दैट आइडिया, ठीक है, वो सब ठीक है, बट मेनली इफ दे आर थिंग्स इन फेज, देन इलेक्ट्रॉन होने के चांस है वहां पे, होगा नहीं मालूम, हो सकता है। इफ दे आर आउट ऑफ फेज, देयर इज नो चांस ऑफ इलेक्ट्रॉन्स। किस चीज का आउट ऑफ फेज? ऑफ फेज वेव्स। कौन सी वेव्स? वो कॉम्प्लेक्स नंबर वाली वेव बताई थी ना, कौन सा थिंग? श्रोडिंगर वेव इक्वेशन। विल टॉक अबाउट दैट नेक्स्ट क्लास में, ठीक है, ठीक है। बट सिंस हम लोग इलेक्ट्रॉन वेव की बात कर रहे हैं, टडा, ओके, निधि होता है यार, लोग बहुत स्ट्रेस लेते हैं लाइफ में, क्या करें? पांडा जी, ऑल राइट, कूल, people have a lot of baggage in their lives, can't judge them, we must try and help them in whatever possible way, at least guide them in what we feel may help them out, उसके बाद तो उनकी चॉइस है, उनकी जिंदगी है, जैसा करेंगे करेंगे। If E1, E2 and E3 respectively represent the kinetic energies of an electron, alpha particle, a proton, alpha particle, helium 2 plus, इसको बोलते हैं alpha particle, ठीक है, a proton, each having the same de Broglie wavelength, then क्या होगा? Take a minute to think about this. Timer 1 minute. Take a minute to think about this. What do you think? अननोन जी, कॉलेज मत जाओ। कॉलेज क्यों जाना है? कॉलेज जाना जरूरी थोड़ी ना है। मैं बहुत बड़ी बात बोल रहा हूँ, सोचो इसके बारे में। आई नो स्टूडेंट who's pinged me. I'm not going to take his name. I don't think he wanted, but he is having बहुत hardships लाइफ में। उसने नीट या उसका he got a score of 600, 595 स्कोर आया उसका। He is not going to get any college with that. And he is one of those students who's been working really hard, I know, but he's facing hardships. उसको the only option he has is to start, उसको तुरंत नौकरी मिल, वो सब something has worked out with him somehow। एक बहुत ही दुर्घटना हुई उसके साथ, जिसकी वजह से उसको कुछ और एक गवर्नमेंट नौकरी मिलने के चांस है, तो नाउ दिस इज इट, ही हैज टू मेक द चॉइस ऑफ टेकिंग अ जॉब एट द एज ऑफ 18 ईयर्स ओल्ड, पूरा घर संभालना, या फिर से ड्रॉप लेना। एक बार ड्रॉप ले चुका है बेचारा। बेचारा नहीं, इज अ वेरी, बहुत हिम्मत वाला लड़का है, बट हार्ड चॉइसेस मैन, लाइफ इज हार्ड। तो जीना जीना है, किस चीज के लिए जीना है वो सोचना पड़ेगा। यू हैव टू फाइंड अ ड्राइव, and the drive has to be a spiritual drive. Material drives don't last. So you have to find the will to do things. That is what differentiates humans from everything else. खैर, इस वाले का आंसर क्या होगा? आपको क्या लगता है? Anyone giving me the answer to this? We'll talk about this unknown. You're talking about very heavy things. I think I'm completely open to such conversations. That's why I got into this line, because I want to be there for people to at least guide them in the direction. ये देखो, ये ह्यूमन फॉर्म ऑफ लाइफ बहुत बहुत ही दुर्लभ है, उसको यूज करना चाहिए सोच के। यू कैन गो टू द डिस्कॉर्ड लिंक्स, वी कैन चैट देयर, टेलीग्राम, जहां पे भी। इस क्वेश्चन को कैसे सॉल्व करें? लैम्डा इज h by p, एंड फॉर इलेक्ट्रॉन हो, अल्फा पार्टिकल हो, प्रोटॉन हो, सेम थिंग है, बट दे आर इक्वल। ओके, दे सेइंग दैट de Broglie wavelength इक्वल। ये मुश्किल हो गया क्या सवाल? दिव्यांका, निधि, मैथिली जी, ये मुश्किल हो गया क्या? कृष्णा जी, शोमेकर, मैथिली कुछ और बोल रही है, रुको, व्हाट आर दोज इक्वेशंस? नहीं, definitely not. I haven't heard of those equations and they never asked anywhere. For sure, Maitli. Lambdas are not equal. I'm sorry. The lambdas are equal. Yeah. Okay. Lambdas are equal, which makes what? Which means that P is equal. Okay. Why? Because this is constant anyway, right? मतलब कि momentum same है. Remember, it's saying that momentum is same, not the velocity. Momentum same है, मतलब कि mass तो अलग हुआ तो velocity अलग हो जाएगी. But here's the thing: if the momentum is the same, what does energy depend on? Oh, energy is proportional to half mv square. थोड़ा messed up नहीं लग रहा है? You know what to do? Multiply with m and with 2. You get 2m ke gives you p square, है ना? वही same चीज, p square by 2m. That one formula is coming to rescue us once again. Okay. So जिसकी kinetic energy हुई सबसे ज्यादा उसकी होगी सबसे लोएस्ट वेवलेंथ. सिंपल सा आइडिया है. ओके. और किनेटिक एनर्जी क्यों ज्यादा होगी? देखो पी सबका सेम है. डोंट हैव टू गेट इनटू डिटेल एट ऑल. द p value momentum is the same. So now the only thing that's different is the mass. Kinetic energy is inversely proportional to mass. So जिसका मास ज्यादा हुआ, जिसका मास ज्यादा उसका kinetic energy हो गई कम. Hey, hold on, what's happening here? You think it's C? Nidhi thinks it's C as well? Okay, cool. देखते हैं. तो जिसका अगर किनेटिक एनर्जी ज्यादा हुई तो होगा उसका लोएस्ट मास, राइट? ओके. और अगर लोएस्ट मास हुआ तो हमको क्या करना? हमको एनर्जी देखनी है ना. वी डोंट हैव टू वरी अबाउट दिस. ओके, सेम रिवर्स. ओके, एनर्जी देखनी है. ओके, कूल. सो आउट ऑफ दिस डेफिनेटली E1 which is electron will have the highest energy because उसका सबसे कम मास है. So let's eliminate these two. Okay. स्मॉलेस्ट कैसा होगा? अल्फा का. अल्फा पार्टिकल या E2. ओके, this is it. Hence C is the answer. That's it, bro. That's it. Simple, easy to do. Good job. दिव्यांका आंसर तो दे यार. हंस तो रहा है, बहुत अच्छी बात है. आंसर दे दे. Let's go on to the next part of today's session, which is Heisenberg's uncertainty principle. इन भाई साहब ने ये बोला, this guy completely destroyed what Bohr did. Okay, like completely, literally खत्म कर दिया बोर के काम को. Yeah, like destroyed Bohr's work pretty much, and he was right for it. Bohr also was partially right because even though his theories failed, we stand on the shoulders of giants and all that, right? So what Bohr started is what Werner Heisenberg built on. Heisenberg, he said that it is not possible to exactly decide the position and momentum of any microscopic particle. इसका ये बोलने का मतलब था कि अगर I get this crazy instrument that can take a snapshot in time. What is snapshot? मैंने फोटो ली, मतलब कि आप जहां पे भाग रहे हो, statue. I get such a fast camera that somehow I'm able to see exactly where you are at in position. I get X. But in the time I take to measure that X, उसकी velocity बदल गई. Do you follow? दूसरा एग्जाम्पल लेते हैं. Somehow, if I'm moving very quickly, so this particle is moving, and I have to move along with it to observe the velocity. But since I'm doing that, भाई साहब की position बदल गई. That's the problem. Okay, because there is a massive change in position and velocity, there's going to be an error, and the error, it looks like it's very small. The multiplication of this has to be greater than or equal to h by 4 pi. This is definitely a quantum idea, guys. I cannot get into the the details of this or derivation of this. Is way beyond the scope of anything. Mug karna padega, sadly. Okay, and this will help you. By the way, why will you have to mug it? Because modern physics, maybe it is very useful. If you want to talk about how this got derived, everything, again, complex numbers, waves, करके आओ, उसके बाद हम लोग बात करेंगे. For sure, I will tell you the logic. It's just that at this point in time, logic is going to go over your head. Okay, so this guy said that the multiplication of the momentum and the distance, the position of the particle, is going to be greater than or equal to h by 4 pi. There's also something called h bar that is usually given, that is h by 2 pi is known as h bar. It's just a mathematical thing. Okay, so h by h, if you see h bar by 2, it is the same as h by 4 pi. ठीक है? Mass to particle same रहेगा, so I can say delta x into delta v is greater than or equal to h by 4 pi m. ठीक है? That's what he said. Interestingly, another way to look at this is the change in energy with time. Ooh, energy and time? How did that work out? How did that work out? Can you get to this from here? Can you get from this to here? MLT minus 2 is energy. हाँ, ये याद है फिजिक्स से? It's easy, Divyanka. That's great. Do you know this? Divyanka and Nidhi obviously knows this. Unknown, and if you're still here, Maithili, MLT minus 2, yeah, that's energy, wavelength. ML2, sorry, ML2 T minus 2. Okay. Okay. What is this? What is P into X? What is P? P is M square V square. What is that? M into V, sorry, M into V. That is ML T minus 1, right? M into V is MLT minus 1. Okay. What about P is MLT minus 1. Into X कितना हो जाएगा? It will become ML2 T minus 1. Okay. So if I do energy into time, then this becomes ml2t minus 1. That's a dimension of this. Yes, this has the same dimension of delta p into delta x. Units and dimensions, guys, these are your best friends. If you're not comfortable with this, please get comfortable with this. Okay. Yes, exactly, Divyanka. Crazy, right? Good morning, shorts. Which part of the world are you from? Divyanka, uncertainty in measuring its energy. If I measure its energy perfectly, उतने समय में भाई साहब का time बदल जाएगा. Right? Which makes sense. If I'm measuring something energy, time. Okay. If I'm able to measure कि okay, at this point in time exactly यहाँ पे है, how much time is it taking to figure out, उसकी energy बदल जाएगी. Yeah. Shorts, I have explained this already. Okay. I have explained this already in my last sessions. You can check it out. Uncertainty in measuring time, not in time. This is not a time travel thing, Divyanka. It's not that cool. We're talking about uncertainty in measuring these values, measuring time. You're not sure if it's 1 second or it's not one. No, it's 10 power minus 9 or 10 power minus 10, or it's of that order of magnitude. That's the measuring of time. इतने छोटे time gap में energy बदल रही है, कुछ हो रहा है. ठीक है. If you want to talk about angular momentum, Mr. Shorts, that also has to do with quantum mech ideas. It's mvr equal to nh by 2 pi, right? We have done those derivation boards. Please check it out. Shorts, go to those links. Shorts is talking about it. I don't want to leave anybody hanging. And hey, I get to promote what I've done, so why not, right? They're wonderful sessions. Everybody should see them if they're studying this. You see this, bro? Shorts. Here you go. That's the playlist for everything I'm doing in 11th grade. You can check it out there. This is the one. Bohr's model, part 3. This is the video. Oh, ads. I hate ads. Ads. All right, cool. Back to our session. All right. So, this is interesting. If I use a wavelength to locate the position of the particle, then there is going to be a difference in this as well. Look at that. This is going to have an error as well. Okay. Like, bro, then what doesn't have an error? Now, what is the biggest problem with all of this error business? Bohr bhai sahab ne bola कि I can locate exactly this is the orbit. I can pinpoint कि यहाँ पे electron. That is wrong. You cannot. You don't know where the electron will be. There is no way for you to know कि electron will be exactly in this orbit. That was the problem with Bohr. Bohr said radius is fixed. Bohr said velocity is fixed. Bohr said energy is fixed. None of these things are right. But they are also right. What? That's complicated, isn't it? The energy part works out because the time doesn't matter so much. But these guys, whew, you can't say that radius and velocity is right. If you measure the radius, then the velocity goes off. Sure, Pranav, we will do that. Aapka hukm, sar aankhon par. Coming up for Pranav, just for Pranav. Yeah. If you try and get an accurate measurement of this, you mess up everything else. For photon, you got E equal to hc by lambda. If I'm trying to measure this, energy ka jo hai, error increases. So irrespective of what particle you're doing or anything else you do, you're going to mess up something or the other. Okay. So let's look at a question. Since you guys are sure about this, let's go ahead and look at a question. Yeah. So see the error in this thing. This is important. Okay. If you do delta x in m into delta v, let's say that the velocity is some value that you know. Okay. Is equal to h by 4 pi m. So into both of these things, this is a very, very big error. Why is it big? Because delta v is going to be of the order of 10 power 2 or 10 power 3. That means delta x is going to be of the order of 10 power minus 7. That's huge for an electron. That's the dimension of the earth, right? If you go from 10 power minus 10 to 10 power minus 7, that's 1000 times. The diameter of the earth is 6000 kilometers or something. So it's a crazy error. Okay. So if x is 10 power minus 8, the velocity is 10 power 4, which is the order of magnitude of the velocity itself. Okay. ये सब आप try करके देखो. I know Pranav wants me to solve questions, but I would really like it if you guys also made some effort and did things by yourself. All right, cool. So these are the general ideas, right? If you have a velocity that's this small, this doesn't make sense. Ignore this. This is whatever. For large particle, it's not going to work. I've already told you, right? Just like the wavelength for a large particle is useless, the uncertainty is not useful either, right? So here is the general idea, right? Here's a question. Pranav wants a question. Here's a question for Pranav. The uncertainty in position of a particle of 25 gram in space, 10 power minus 5 meters. What is the uncertainty in velocity? Batao bhai. What do you think this is? Can you do this? It will be negligible, exactly. But how negligible? Let's go ahead and calculate kitna negligible. Can you guys do that? Put some number to it. That's great, Shri Krishna. Yes, she's a wonderful teacher. I agree. Can you guys try this question out, please? Very doable, I feel. Not rocket science at all. Delta x into delta p is greater than or equal to h by 4 pi. Literally just substitute all of these things. The only thing you gotta do is कि ध्यान से arithmetic करो and you'll be good. You'll be good. Yeah, let's try this, please. Yeah. प्रणव भाई को चाहिए तो सवाल, बट सवाल दिया तो जवाब नहीं देंगे. I'm gonna wait for like 10-15 more seconds and I'm gonna go ahead and solve this anyway. It's not that complicated. It's very doable, I feel. है ना? Quite doable. So, substitute all these things. Delta x is 10 power minus 5. Delta p is what? M into delta v. Mass मैंने यहाँ पे डाल दी. 25 gram मतलब 25 kilogram. And this is what? H by 4 pi. I've taken pi b 25 by 7. Okay, so we can get delta v, I think. We can get delta v. It's going to be very, very small. It's going to be very small, so it's negligible, right? So take stuff to the other side. I have conveniently cancel stuff out, okay? This is 4. 1.4, sorry. 1.45, which is what I've written over here. 22.7 ये सब यहाँ पे मैंने लिखा हुआ है. Cancel करो चीजें. Approximately, you get it to be some ridiculous number, 10 power minus 28. And the answer right here is going to be approximately 2 into 10 power minus 28, which is A. So you can see that it's insignificant. It really doesn't matter. Okay? So, again, proving to you कि ये जो uncertainty principle है, it only matters for microscopic particles. Okay, so let's take a microscopic particle. Okay, great, Pranav, you're alive. एक और देखो. Next one, Pranav, just for you. The uncertainties in the velocities of two particles A and B are 0.05 and 0.02 meters per second. The mass of B is 5 times to that of mass of A, the ratio of mass of A to B. What is the ratio of uncertainties delta XA by delta XB in their positions? Good job, Pranav. Excellent work. ये वाला try करो. Same idea use करना है. यहाँ पे the only difference I've written h bar by 2, which is the same as h by 4 pi. Confuse मत हो, डरो मत. Delta x by delta b is directly going to be equal to delta p b by delta p a. Q. Is this correct? Is this not right? What do you think? Can we do this? Try this out, please. Sure, take your time. This says 2. That was quick, Nidhi. I'll give you another minute, Pranavji. Took 2 minutes. Timer 1.5 minutes. Na tera na mera. 90 seconds. Let's go. Lovely work. इतना ही टाइम लेना होता है सवाल करने में. देखो, why did I write this? Because this is a constant ना, so I'll take it to the other side. Let's take it to be equal to greater than sign हटा दो. ठीक है? MB is 5 times MA and delta VA is 0.05, delta VB is 0.02. Substitute mass into velocity, है ना? तो XA will be equal to MB into VB divided by MB, MA into VA. ठीक है? Substitute सब करिए. ये है, ये रेशियो MB by MA is 5. This is same as MB by MA. And यहाँ पे क्या है? This is VB and this is VA. That's it. So 5 into 2 by 5, which is, well, half of this. 2.5, which is 2, sorry, not half, it's 2. A is the right answer one more time. एक और सवाल, दिव्यांका, रश्मिता, good job, lovely, lovely. You got on fire. एक और सवाल, ये वाला मजेदार. This is a nice question. I like it. If uncertainty, position, and momentum are equal, then the uncertainty velocity is what? I'll give you a minute to do this one. Again, timer 90 seconds, a minute and a half. Pranav, any doubts you have, go to that link. I'll show you right now actually. I'm half afraid of doing this live, but I have confidence that the people who are on the server kuch harkatein na kiye honge, hopefully. So I can show you what I do with doubts. See, the way things are, how much I want to help you, I have a finite amount of time in life. So what I did was I created this, okay? A Discord server, which goes there. And what you can do is go here. Yeah, hold on. How do I share this with you? Doubts. Okay, all right. Hold on. Share my screen. How do I share the screen that I want to share? Let's share the screen with you. Here you go. This is what it looks like. All right. This is the doubt section on my server. I run a Discord server. Look at this. It's got hundreds of doubts. Literally, you can scroll all the way. And this server is it's under 2 months old. I'm not kidding. I made the server on April, what? Sometime like April, whatever. It's less than 2 months old. Okay. There are a lot of doubts. A lot of these doubts are solved. It's a wonderful place. Come check it out. Because Pranav wanted to ask a doubt. I'm going to come back to this. Okay. The other way to ask a doubt is go to the Byju's site and literally click on ask a doubt. Go to the Byju's thing and say ask a doubt. And you can ask whatever doubt you want there. All right. But if you want to ask live doubts, which I know is the biggest thing that students want, you can go there. I'm going to go back to the question I was solving because that's my priority here. Okay. You think option A is here? All right. Yeah. Invisible जी जरूर करिए, प्लीज हेल्प करिए. ओके सर 22. ओह अच्छा 12th में कुछ नहीं आता, कुछ और कर लो यार, मत करो इंजीनियरिंग, क्यों करना है? इनविजिबल जी आई यू आर देयर फ्रॉम लॉन्ग टाइम, थैंक यू फॉर स्पीकिंग अप. क्यों करना है इंजीनियरिंग? देखो जो मन है वही करना चाहिए. आई एम नॉट डिस्करेजिंग यू, आई एम सेइंग जो मन है उसके पीछे भागना चाहिए. इनफैक्ट यू शुड पुट ऑल योर एफर्ट. एज अ ह्यूमन बीइंग यू हैव सो मच इनफाइनाइट पोटेंशियल. यूज इट यार, मजा आए तो उसको करो एंड जान लगाए करो, मन लगाए करो. श्योर. या delta x and delta p is greater than equal to h bar by 2. Okay, h bar is same as h by 2 pi. So I'll write it as m delta v. Why am I writing it like this? Because if I take delta x equal to m delta v equal to some k, then I can say that k square is greater than equal to h by 4 pi. क्यों? क्योंकि यहाँ पे दिया हुआ है uncertainty position delta x and momentum delta p are equal. So delta x equal to delta p equal to k. यही मैंने delta p को m delta v, we are assuming mass doesn't change. Okay. There is no delta m. At our level नहीं बदलता है भाई, मास नहीं बदलेगा. ठीक है, मत करो ये सब. डोंट थिंक अबाउट मास चेंजिंग राइट नाउ. रिलेटिविटी हम लोग नहीं पढ़ रहे हैं. कुछ लोग होंगे जो ये सब बोलेंगे तो उनके लिए बोल रहा हूँ. ठीक है. तो k इज ग्रेटर देन इक्वल टू h बाई 4 पाई. अब क्या करें? अब यहाँ पे तो कुछ m m लिखा है. ओ बिकॉज हमको निकालना है अनसर्टेनिटी इन वेलोसिटी, राइट? परफेक्ट. सो टू गेट अनसर्टेनिटी इन वेलोसिटी व्हाट डू वी डू? क्या करें क्या ना करें, ये कैसी मुश्किल. हाय, व्हाट टू डू नाउ? अच्छा 4 को बाहर निकाल लेते हैं. comes 2. Delta V is greater than equal to 1 by 2 h by 4 pi. Why? Because k क्या था? K was m delta V. Take m to the other side. खत्म. m कहाँ गया? तो 2m होना चाहिए. ठीक है. This marks with option C. This goes option C. Good answer. Good answer. वाह वाह वाह. इसीलिए आए तुम. IIT में कैसे जाओगे यार? If you're saying you don't know delta, bro. If you're here to troll me, I'm not in the mood. Okay, if you're serious, then please, you know where to reach me. Okay, trolls का मेरा बहुत ही low tolerance level है, especially live channels पे. Real life में जितना करना है ट्रोल करो, आओ भाई बात करो. इंटरनेट पे पीछे आके स्पैम करते हो भाई, ये तो शोभा नहीं देता है. खैर, C is very good. Pranav, you think it's A? Pranav, I think what the problem with A was that it had A में ये 2 वाला फैक्टर हट गया. ठीक है प्रणव, let me show you that again once more. देखो h by 4 pi था ना, this 4 you need to have that 2 wala factor here. Okay, please don't forget that. Oh, that's awesome, dude. Anish, yeah, I am at Byju's. This is Byju's. Divyanka C, yes, all right. Of course. Byju's exam prep. Yeah. BEP, Anish. I have been a part of that in some form or the other. Good to hear. Good to hear. All right. So, review of everything we've done so far. बहुत चीजें की हैं, बहुत कंफ्यूजिंग चीजें की हैं, भारी भारी चीजें की हैं. What was black body radiation? There was some difference between theory and observation. Some more questions. I'm out of time, my friend. जितने सवाल करने हैं, go to NCERT, please solve questions. I'll do a tutorial session. अलग से करूंगा मैं. I will do tutorial session. Don't worry about it. Yeah, we'll do it there. Yes. We'll do questions. Don't worry. There was a difference between theory and observation. Do you remember this? Black body radiation में, this was reality. Okay. But classical mechanics बोल रहा था ये होगा. And it failed. It was called UV catastrophe. इसलिए we needed a new theory, which is where the whole quantum thing came. Then Planck भाई साहब ने बोला, देखो, E equal to h nu. I don't know how, I don't know why, but E is equal to h nu. So, because he said E equal to h nu, life became easy. It explained everything. It worked out for this. It's beautiful, just because of that. An oscillating object could only take on specific value. What is oscillating? Electromagnetic waves. Waves are oscillating, right? That was a hard thing for me to teach you because you guys have not learned wave. You guys have no idea what is oscillation. So, but anyway, once you do physics, it will be good. Okay. Photoelectric effect, Einstein भाई साहब ने जो बोला, yeah, he said that look, light can behave both as a wave and a particle. De Broglie, आज हमने सीखा. This was a recap of the first 4 sessions. De Broglie भाई साहब ने बोला कि अगर light behave करेगा like a particle, then particles also will behave like waves. And we've seen today's session कैसे होता है. बोर मॉडल ने बोला हाइड्रोजन एटम अदर सिंगल इलेक्ट्रॉन स्पीशीज को, ठीक है, हम लोग एमिशन स्पेक्ट्रा को एक्सप्लेन कर सकते हैं. हाइड्रोजन एमिशन एंड अब्जॉर्प्शन, वी डिड दैट इन द लास्ट सेशन. हाइसेनबर्ग्स प्रिंसिपल सेड कि बॉस, बोर आपने बहुत बड़ी गलती कर दी बोलने के लिए कि इट इज नॉट पॉसिबल टू गेट पोजिशन एंड मोमेंटम ऑफ एन इलेक्ट्रॉन एट द सेम थिंग. ओके, सो इंस्टेड ऑफ सेइंग exact position, instead of saying Rn and Vn, what he did, now this is the introduction to quantum theory, he said कि चांस होती है, ठीक है. हाँ, सुब्रमणी साहब डिस्कॉर्ड पे आइए, जो बात करना है करेंगे. अभी तो पढ़ाने दे यार, एटॉमिक स्ट्रक्चर पढ़ाने के बारे में पढ़ाने दे, ठीक है. he replaced this with probability, मतलब कोई चांस. how does this probability thing come into being? Okay, this is what forms the basis of quantum mechanical model of the atom. Because Bohr could not explain this. Okay, एक इलेक्ट्रॉन का he was great. He was very good in figuring out one electron species. But multi-electron species में कुछ अलग ही चीज हो रही थी. Instead of lines, he was saying bands. Okay, if you study IR and NMR spectroscopy, you will see bands. Okay, you will not see lines, and that was only because of quantum mechanics. You can't explain it using Bohr's model. Okay, first drawback. Next drawback. He could not figure out कि अच्छा एक लाइन के बजाय दो बहुत ही पास में लाइन होगी. Again, not possible. बैंड वाला चीज मैंने बोला था, that was there. Okay. Magnetic field और electric field के कारण Zeeman effect and Stark effect could not be explained. Now, what on earth are Zeeman effect and Stark effects? आओ भाई डिस्कॉर्ड पे, I'll give you links to read. अभी हम लोग सेशन में बात नहीं कर सकते इसके बारे में. जबरदस्ती आपको एनसीईआरटी में बोल दिया Zeeman और स्टार्क इफेक्ट के बारे में, जो हम लोग पीएचडी में जाके पढ़ते हैं भाई कैसे यूज करते हैं. बट ठीक है, बोल दिया एनसीईआरटी में, तो मैं भी आपको बोल रहा हूँ. Yeah, and this was the craziest thing. This MVR equal to NH by 2 pi. You're like, what? How did that happen? That's crazy. What are you talking? What is NH? What is NH 2 pi? Could not explain. Okay, he could not figure out de Broglie's concept or Heisenberg's uncertainty principle. And lastly, dude, and this is the craziest part, I'm not kidding, he could not explain why do bonds get formed. What is that about? Like, wait, what? If atomic structure can't explain how bonds are formed, what's the point of atomic structure? Baby steps. Which is where the quantum mechanical model comes to the picture. ठीक है, इसको डेवलप किया हाइसेनबर्ग भाई साहब ने and Erwin Schrödinger. Okay, considering this idea कि microscopic particles behave both as a particle and a wave. Okay, so think about it like this. एक बहुत ही rudimentary idea है. I'm just giving you some basics, some things to think about. बाकी हम लोग बात करेंगे परसों on Saturday. कॉइन को टॉस करो, बोलते हैं ना कि कॉइन, अनबायस्ड कॉइन को टॉस करने की प्रोबेबिलिटी 0.5 है. इसका क्या मतलब है? इसका ये मतलब नहीं है कि मैं अभी एक बार टॉस करूं तो हेड आया, दूसरी बार टॉस करूं तो टेल आया. नो, इफ आई डू a million maybe 10 million, then maybe I'll get an equal number of probability. I'll get 0.5 if it's an unbiased coin. इसका ये मतलब है I have to do it many times. So this was the important thing, because atomic particles बहुत छोटे हैं, बहुत ढेर सारे हैं. I can kind of using statistics say कि हाँ, with some doubt इस एरिया में एग्जिस्ट कर सकता है इलेक्ट्रॉन. दैट इज व्हाट वी आर सेइंग. ठीक है, कूल. रीड अप मोर अबाउट दिस, इज वेरी इंटरेस्टिंग एंड आल्सो वेरी हेरी. मतलब ये क्या हो रहा है, बात किसी को समझ में आता नहीं क्वांटम मैक, बट वी ट्राई एंड अंडरस्टैंड एट आवर लेवल. वी ट्राई. ओके, दिस वाज द श्रोडिंगर वेव इक्वेशन. ऑलराइट, कूल. ऑलराइट, सी यू निधि. प्रणव जी, क्या यार, हम आए यहाँ पढ़ाने के लिए, तुमको टाइम पास करना है. टाइम पास जाके कहीं और करो भाई, हम पढ़ाने आए हैं. Schrodinger with umlaut. Okay. So, how does he decide कि इलेक्ट्रॉन कहां पे होगा न्यूक्लियस के बाद? मुद्दे की बात ये. आफ्टर दैट विल टॉक अबाउट बॉन्ड्स, बट इलेक्ट्रॉन है कहां, पहले ये बताओ. ये हैव यू सीन दिस sin x? You know sin x? Okay. I have told you that there is a function. Functions पढ़ा है, मे बी शुरुआत में, इवन 11th फंक्शन शायद पढ़ा होगा आपने, राइट? 12th में शुरुआत में, 11th में शुरुआत में फंक्शंस पढ़ाते हैं. ओके. इफ यू डिफरेंशिएट दिस, डिफरेंशिएशन पढ़ा है? नहीं पढ़ा होगा. डिफरेंशिएशन नहीं पढ़ा 11th स्टूडेंट्स ने. Come back to this when you know what differentiation is. When you differentiate this, you get some function, some other function. The funny thing is, when you differentiate it again, you get back the same function. Okay, this is what was used in quantum mech. ठीक है? You get such a function that the second differential of the function is equal to some constant times that function itself. Do you understand what I'm saying? एक फंक्शन है y, और या मैंने psi ले लिया. psi इसलिए because it's going to come up later on. ठीक है? That's the function I have equal to some value. I differentiate again. I get some constant minus m square is basically equal to e. That is the Schrodinger wave equation. ये है एक वेरिएबल में और for one dimension. What is the dimension? x square. This is very complicated, but जबरदस्ती तुम्हारे एनसीईआरटी में दिया है, इसलिए मैं तुमको बता रहा हूँ. ठीक है? V is the potential energy, E is the allowed energy of the particle. Now this allowed energy comes from allowed energy. Ooh, you remember E equal to h nu, packets discrete. Allowed energy has to do with this quantization idea itself. Key, the solution of this equation gives you that allowed energy की value. ठीक है? This whole thing here is some constant, so I'll put some constant over here. This is in 1D. I can make the same thing in say 3D. Okay, we'll do that, but before that, this can take real values. Why am I taking real? Because this is a complex equation. By complex, I don't mean कि complex I can't teach you. Complex मतलब complex numbers है भाई. There's something called I and all. Okay, so we'll talk about this when we do this again. It'll take real solutions only if E takes specific integer values similar to that E equal to h nu. These specific integers are what इसके solutions give you this. ओके, हैव यू सीन दिस? बहुत लोग इसको मग करते हैं, क्वांटम नंबर्स बोलते हैं. ठीक है, बट दिस इज वेयर क्वांटम नंबर्स कम फ्रॉम. सॉल्यूशन टू द श्रोडिंगर वेव इक्वेशन, इफ यू हैव नॉट अंडरस्टूड एनीथिंग, ये सुन लो. सॉल्यूशन टू द श्रोडिंगर वेव इक्वेशन इज व्हाट गिव्स यू दीस क्वांटम नंबर्स. ओके, सो यू सॉल्व द श्रोडिंगर वेव इक्वेशन टू गेट द वैल्यूज ऑफ साई एंड द करस्पॉन्डिंग एनर्जीज. ओके, एंड इससे तुमको पता चलता, अच्छा मे बी पार्टिकल विल समवेयर ओवर हियर. This is what we'll do in the next session. ठीक है? Psi has no physical meaning. Then why are we studying it, bro? Because psi square has a physical meaning. That is what gives you the probability. And इसके बारे में हम लोग अगली बार बात करेंगे. Learn differentiation. That's great, Pranav. Lovely. पढ़ लिया तो बहुत अच्छी बात है. If you learn differentiation, remember that y equal to sin mx, y dash is equal to minus m cos x, y double dash is minus m square sin x. इसको याद रखो. Similarly, this right here, right? This is called an eigenvalue function. When you have this sort of an equation, right, where the second differential of this is called an eigenvalue function. ठीक है? इसी के बारे में हम लोग बात करेंगे अगली बार. And इसका solution of this you get quantum numbers. Okay, इसके बारे में हम लोग बात करेंगे अगली बार. I overshot the time that I wanted to spend with you guys on this session by 5-10 minutes, but it's okay. I hope इसमें मजा आया हो. इसमें थोड़ा सा कॉम्प्लिकेशन लग गया होगा या थोड़ा सा भारी चीजें बता दी मैंने आपको, बट खैर, this is what atomic structure is all about. I'll see you next time for starting the wave equation. Please solve the NCRT. Till then, I'm going to quickly share my screen again to show you where we are at on NCRT. अरे तो Discord का सर्वर चल रहा है, रुको. Let us go back to Edge. Okay. Oh no, wrong thingy. PowerPoint था. Okay, hold on. This is where we are going to go to Edge. Alrighty. Okay, Edge. Where are we on Edge? क्या बता रहे थे? हाँ. Here, see. Coincidentally, I have H psi equal to E psi. Hamiltonian operator. ये सब बहुत भारी चीजें लिखी हुई है भाई. खैर, on the next episode हम लोग बात करेंगे ये सब on Saturday, June 8th. Okay. Every time I give you a date, something happens and I don't make that date. I hope I make this date and I don't fall sick or some random thing like that. We have done all of these things. What do I want from you? Please यार, इसको करो तुम लोग, ठीक है? Do this, read all of this and come. Life will be a lot easier. Yeah? शार्या, प्रणाम. बढ़ क्या हो यार? प्रणव सिखाया तो है, तुम आए नहीं, तो मैं क्या करूं? सब सिखाया है. देखो, go to this link. Here you go. अगर और कुछ नहीं करना तो भाई इस लिंक पे जाओ. Scroll all the way to grade 11. Go to structure of atom. Go here. Go to Bohr's model. फिर देखो ना, इसमें सब बताया हुआ है. ठीक है? चलो. Thank you everybody for your time. I will get going right now. And hold on. But सबसे जरूरी चीज, पढ़ो. Please read all this and come. In my next session, before Saturday, read all this. Yeah? ऐसे नहीं कि मुंह उठा के आ गए यहाँ पे, भाई मुश्किल होगा ये if you do that. I will try my best to transfer whatever knowledge I can in this 1 hour period time, but you must read books. You must read good books. That's the only way to do well in this. मजा आना चाहिए, अदरवाइज तुम बस मग कर रहे हो यार. मग करने के लिए वीडियो देखने की जरूरत नहीं है. मग करने के लिए कोई शीट देख लो, कुछ भी कर लो, मग वॉमिट कर लो भाई. If you're here, I hope you take something positive out of here. थोड़ा इंटरेस्ट तो जगा लो यार. Read this. Alright? ठीक है, मिलते हैं सैटरडे को. कल आई एम मीटिंग यू गाइस, बट आई एम गोइंग टू आईआईटी के क्वेश्चंस इफ यू वांट टू डू दैट. आपके सीनियर्स के लिए में मोर रेलेवेंट. आई एम गोइंग टू आईआईटी के 2022 एंड 2021 के सेशंस. If you want to see that, hold on. I'm going to go back to this. This is the Aakash Byju's site, right? Playlist, nahi, live ka hai. Yeah, I had to change this. It looks like Q looks like an A there. I'm doing this tomorrow, all right, at 8:30 p.m. All right. Oh God, dude, what are these guys? Like seriously, मेरे पास कोई काम नहीं है लाइफ में बैठ के इन लोगों को. Oh, I can't do that here. Look at these guys. Anyway, see you all. Bye bye. Tada. मिलते रहेंगे. That's me. I have a mustache.